We didn't get to go over this very much in some of my classes, so I wanted to do some extra examples on the two-step inequalities homework that we had. And so I'm going to pick some different ones, some different types, and do those together with you. So on number 1, you have 2x plus 4 is greater than or equal to 24. So I always like to draw my balance line, and that's just like my reminder, just like when we do equations. If I do it to one side of the inequality, I have to do it to the other side of the inequality to keep my inequality true. So the first thing I want to do always is isolate my variable. So I want to get rid of the constant 4. So the zero pair for positive 4 is negative 4. So I'm going to subtract 4 from both sides. So 4 minus 4 zeroes out. Bring down the rest of my equation that I have left. 2x greater than or equal to 24 minus 4 is 20. Now I have my variables on one side and my constants on the other. They multiplied. Whenever a coefficient is attached to a variable, it means that they multiplied. So we're going to do opposite operations, and so we're going to divide both sides by 2. So whenever you have any number over itself, you have that becomes 1. So these 2's become 1. All we have left on this side is 1x is greater than or equal to 10. So the way we graph it on a number line is when it's greater than or equal to, we bubble in our dot because it's that number plus all the numbers greater than or equal to that number. Okay? Now let's do number 3, where we have to multiply. So we have m minus 3 over 2 is less than or equal to 5. So what this 2 in the denominator, we want to get rid of that, and so we're going to multiply both sides by 2. So I'm going to come down here and explain why we do that, because let's say that the m minus 3 on the top is just 1, and so we have 1 minus 2, and we want to get rid of that 2. What you would multiply 1/2 by is the reciprocal to get rid of the fraction and make it a whole number. So if I multiplied that by 2 over 1, which is just 2, 2 times 2 is 2, 1 times 2 is 2. So now that becomes, any number over itself is 1. So that's why we multiply by the denominator to get rid of the denominator. So this becomes 1. All we have left over here is m minus 3 less than or equal to 5 times 2 is 10. So now now that I've gotten rid of my denominator over here, opposite operations, they subtracted 3. We're going to add 3 to both sides. I forgot to do my balance line. And then this becomes 0, and we have m is less than or equal to 13. The way we draw that on our number line is it's also equal to, so it's shaded in, and that shows less than. Okay, now I want to do one with a negative number, because whenever we multiply or divide by a negative number, we have to flip our signs. So let me get another. So I'm going to do 9. Let's go down here to 9. negative 7x plus 7 is less than or equal to negative 56. I want to isolate my variables, so I'm going to get rid of this constant. The zero pair for positive 7 is negative 7, so I'm going to subtract on both sides. This zeroes out. I have negative 7x left. Negative 56 plus negative 7 is negative 63. So now I don't want to know what negative 7x is, I want to know what 1x is. So they multiplied here, so I'm going to divide both sides by negative 7. As soon as I realize I'm dividing or multiplying by a negative, I circle my inequality sign to remind me to flip it on my next step. So any number over itself becomes 1, so those two negative 7s become 1. So I have 1x left. I'm going to flip my inequality, and negative 63 divided by negative 7 is 9. So on number 9, I actually have x is greater than, and it's equal to also, so we shade it in, greater to equal to 9. Okay, so I want to do one where it's not shaded in. So let's try number 6. Let's do number 6. So we have 7n minus 1 greater than negative 169. I want to isolate my variable, so I'm going to get rid of my constant. My zero pair for negative 1 is positive 1, so they subtracted, so I'm going to add. So I have 7n is greater than negative 168. Now I want to, they multiplied over here 7n, so I'm going to divide both sides by 7. This becomes 1. I have n is greater than negative 24 because I have a negative divided by a positive. So the way that I graph that is negative 24. I'm going to leave my dot open because it's all numbers greater than 24, but not including 24. So I hope that helps clarify just a little bit. Here, I'll do one more. Let's do number 2. Negative 4b minus 5 is greater than negative 25. I want to isolate my variable, so I need to get rid of my constant. Opposite operations, they subtracted. I'm going to add 5 to both sides. This becomes zeros out. What I have left on my left side is negative 4b is greater than negative 20, because 25 plus negative 25 plus 5 is negative 20. So now I want to, they multiplied here, 4 times b. When there's a coefficient next to a variable, it means that they multiplied. So they multiplied, so opposite operations, we're going to divide. We're going to divide both sides by negative 4. As soon as I know I'm going to divide, I go ahead and circle my inequality sign to remind me to flip it. So negative 4 over negative 4 becomes 1 because any number over itself is 1. All we have left over here is b, and we flip our signs. Negative 20 divided by Negative 4, negative, divided by a negative is positive 5. So on 2, we have b is less than 5. So we're going to leave our circle open because it's all numbers. That doesn't look very open, but it is open. All numbers less than 5, but not including 5. I hope that helps. That's 5 problems on your homework. And I think we went over a couple in class. And if you look on my teacher page, there's several links to tutorial websites that can give you more examples on how to do this.